now I had discussed almost everything regarding the graphs and all. Now let's move to the some good questions, some good problems over the graphs. Okay, so I give you one problem and we'll discuss over it. I hope you'll understand it. So this is again a V versus T graph, one of the useful graph, V versus T, velocity versus time. And okay, let's make it more tough or thoughtful, thought-provoking. V versus X, and it is a straight line. So you can see that velocity is decreasing. I name these points, label. This is 10 meter per second, and say for example this is 4 meter. So what is the question? Question is, you need to find acceleration. Find acceleration at X is equivalent to 1 meter. Previously we just we were hopping from one graph to other graph. We were jumping from one graph to other graphs. Now I asked you some data. If you need to find acceleration, so let's work over it. Solution. So the moment you heard of acceleration, what is the relation between acceleration V and X? So acceleration is V dV over dx. So this must be the first thing striking your mind. What is dV over dx over here? It is the slope of this graph, and it has to be negative, of course. And what is the slope of this graph? Can you see that? 10 over 4. If I represent it with m, 10 over 4 with a negative sign. Okay, this line slope has to be negative. Can you see that? Okay, so minus 5 by 2. Now my only thing is I need to find acceleration. So I know the slope. I need to know just the velocity at X equivalent to 1. And how can I find that? There must be some relation between V and X. Okay, and for that, of course, we can find the equation of this line. Let's find this equation of this line, and we can find the what is the value of V at X equal to 1. What is the value of V at X equal to 1? Okay, let's move to find the equation of this line. Okay, so equation Y is equivalent to mx plus c. I'm going to use this. Okay, Y is equal to mx plus c. Let's do it in a separate paper. So Y is velocity, m is 10 over 4, negative 10 over 4, x is x, and c is intercept, which was 10. So thereby I got the equation of that line. Okay, now if I need to find V at X equal to 1, just put X equal to 1 over here. So V would be X equal to 1. I think X was 1 now. Yeah, so in the problem it was 1. So this would be this. I think that would become 30 over 4 or 15 by 2. So velocity is 15 by 2 at X equal to 1. Okay, velocity is 15 by 2. I just I just form it as a box. Okay, so velocity is this at X equal to 1. Now I need to find the acceleration. Just doing it from the different paper. Acceleration was V dV by dx. What was dV by dx? It was negative 10 over 4. And what was velocity? It was 15 by 2. So that would be the acceleration. Okay, you can further solve it. 5. So minus 75 by 4. You just solve it here. Okay, I think this is the answer. So the thing is 75 by 4 is the acceleration, and negative, of course it is negative because the velocity is decreasing. Can you see that? So this is the answer. Okay, so just I just need to check something. why the shapes are not drawing as per I desired. So let's move to some good question. Okay, so there was a question asked in some examination. It was like this. Say I drop a ball, okay, a ball at a height of this, it is D. So dropped a ball, that means U equivalent to 0. Okay, and it rises when it strikes the surface, it rises to D by 2. Okay, like this, it rises to this height, half of the height. Okay, so I need to draw a graph of, just a second. There is a problem with this, why it's not actually getting, sometimes it's getting shaped and sometimes it's not getting shaped. So the thing is, I need to find a draw, this height is D by 2 when it tossed, bounce back of the surface. I need to draw a graph. Actually, it was a MCQ question and 4 options are being given. So you just need to eliminate the things. You need to draw a graph velocity, between the velocity and the height h from the surface, not from the top, from the surface. Say for at any time height is h. So this is the, at any time, this is the h height from the surface. And what is the velocity at this height? Okay, it is not d by 2 always. At any point it is height. So don't get confused if I draw d by 2. So say for example, this is the height. H is this height, which is of course not d by 2. So if it is having some velocity at this point, say for example, it is having v velocity at this point. So I need to draw a graph between, So question is not drawing. Question is to eliminate the option v and h. But I would, try to make a graph and clarify it to you more rather than just eliminating the option, because which one is the easier one. But let's go with the solution. Let's go with the concept. So for example, if I need to draw, I need to know a velocity at this point. Say for example, this height is h. I need to find a velocity v. Say for example, the velocity here is v. Okay. So can I find the velocity here? Yeah, of course we can find it. V square minus u square is equal to 2 negative g, and the displacement traveled. What is the displacement traveled? D minus h. Simply d minus h. Solve it likewise and you can find the velocity v square. U is 0. So 2g. Can you see that? Okay. And okay, displacement is also negative. So negative positive d minus h. Displacement is also negative, na? It is downwards, na? Don't worry of these things. Negative d minus h. Okay. So this is the case. Can you see that the graph, the nature of the graph between v and h is just a parabola? V and d. V and h, sorry, d is a constant, v and h is a parabola. It has to be a parabola. Can you see that? And the velocity is increasing. So what sort of the parabola? Opening upwards or opening downwards? The acceleration is constant. You also know that velocity and h, it is looking as acceleration is constant over here, but the velocity and h, it is clear. It's not about the x and t. It's not x and t. Okay, don't confuse it with the x and t. Is that why I am taking it, parabola, because x and t is a parabola. X and t, there is no connection with an x and t. There is only connection v and h. Just look at this formula and you can see that it's a parabola and it's increasing, so it's opening upwards parabola. I was just telling it with the x versus t to just make you sure about the shape, but it has nothing to do with the x and t. It has everything to do with the shape. Okay, now let's come to the point. I'm drawing the graph. I'm drawing the solution for that. V versus T. V and T. Previously, the value of H was D only. Okay, just give me a second. The value of H was D only. It was at the top, or velocity was 0. And then velocity was increasing till it become V. And parabolically, velocity was increasing till it become V. Say for example, it become V. And then suddenly, the velocity, direction of velocity changes. It bounces back. Suddenly it changes to, it changes to V, but in the opposite direction. And it goes, of course, parabolically and to a height of d by 2. And to a height of d by 2. So this is the graph. This is the graph. Even you just know how to start, where to start, you can eliminate all the answer choices. Okay. So to eliminate is very easy. You just need to know how and when to start and what should be the nature of the graph. Two of the answer choices were just the straight line. So you can eliminate two answer choices, and one of the two graphs you can eliminate just by knowing it where to start. Okay. So I'll give you another problem, a good problem. That's why I'm discussing it now only, so that you can have exposure of all the good problems. So this is a graph between acceleration and time. Okay, and then this. So make it more good. I make it acceleration versus x graph. So this is x equivalent to 2. This is x equivalent to 3. And this is x equivalent to 4. Okay. So what I need to find here, velocity. Find velocity at x equal to 3. Now this is the question. Now it might look very tough, but the thing is, if you go with the basics, it is easy one. So what is the acceleration? Is v dv over dx. Okay, can I arrange it like this? A dx is nothing but v dv. Okay, say for example, the initial velocity I gave you like 10 meter per second. Okay, 2 meter per second. Take it easy number, 2 meter per second. 2 meter per second. And I ask you velocity at x equal to 3. Okay. So now just look at this. What is this? A dx. This is the area. Integration of a dx. This is the area. Okay. And we can integrate this easily. So let me solve it with other page. A dx is the area till x equal to 3. So what is the area there? You can solve it. That rectangle 20 plus 5. 20 plus 5. Okay. And what would be the area of this? V square by 2. And I can put the limit from 2 equivalent to V. Now you can solve it. 25 V square minus 4 divided by 2. Okay. I hope I'm doing it right. Calculation all. Even you can check it afterwards. So velocity is nothing but root 54 here. Okay. So this is getting easier once you know how to use it. So velocity is root 54. Okay. So that's all for the graphs we have done. Now we'll start with the projectile motion. Okay then, bye bye.